All right, let's see what Ben's up to.
Probably napping. I want to nap. I was doing the proof on number 16.
Naps are good.
And I was like just writing down this whole thing. I was like, man, this is gonna be a long proof. And then I just realized, like, wait, all they have to do is I was like doing this whole thing where I was like drawing auxiliary lines and making triangles. And
Which one were you trying to prove?
Just the proof on number 16.
Okay.
I got it right, but I realized like halfway through I was like, oh, that's you don't know.
Well, I'll argue for Jack's sake is that typically you know if you get a proof right because it either makes sense or you're like, I think this is. If you're thinking that it's not right, but usually the confidence that, well, yeah, that's true. Oh, that's true. That's true. I mean, it's really hard not to know that you got a proof right.
But what if I put my confidence in the wrong area?
Well, that's typically what happens. Like when you say it's ASA, but it really isn't an ASA, then that's where it goes off the rails.
That's probably what I did wrong. I did SSS.
Well, I don't know what it is.
What?
I don't know.
16. Why'd you do SSS? Because I split it up into triangles. It worked like an SSS, but I might be wrong. Look at it.
16?
It would have been AS. No, it would have been AAX. But it was easy.
That's horrible.
No. The other one's parallelogram.
There we go.
Let's see. So, okay, so if I split it in half.
What are you given?
They're
They're both parallelograms.
So
All right, that's congruent to that. That's congruent to
But
that.
you don't need the sides.
No, you really don't.
All you need is the angles.
Yeah.
So then if E is
Then
congruent to
B.
FE,
You guys are killing me.
and
You're
CXA
think about it.
B, then if CXA is congruent to FXD, then by the substitution property you get that B is equal to FXD, and E is equal to.
Yeah, everybody done right there? One step?
Yeah.
Pretty much. Yep, I did not get.
You got to do vertical angles, and then since the parallelogram opposite angles are congruent, so you can call it substitution transitive. This is congruent to this, and this is congruent to that, and that's congruent to that, so therefore that's congruent to that. Done.
Oh, I did triangles at B.
You could, and I'm telling you, you could absolutely
Yeah,
get
that's what I was doing, but I don't know how you would have proven.
maybe like
Well,
that.
yeah, but
ECX
that's what I did, but you can't prove that
But
triangle
I split it
CXA is congruent to triangle FXD.
But I split it across the middle.
Well, I got an SAS right here, and then you can prove this triangle is congruent to that one.
Well, yeah.
Well, can you?
You can't
No,
Well, you can
no.
split it. You can split it
can't.
straight through the
You
middle.
can't prove
That
that
would work.
CXA is
Yeah, I think split it through the middle this way, and then, oh, that would be
No,
ugly.
but then you can't get FE. You can't get E and B because they're split.
I think maybe if you did it
Oh, that's
this
what I did wrong.
and that other method, maybe.
That's what I did wrong. All right, now.
Because all I need to do is show that this side and this side are literally the same, and I think we could get that from this, right? Couldn't we? Let's see. So if we did that, could I get this triangle congruent to this triangle?
Yeah. I don't think so. Well, if
Well,
they're
triangles
no,
say-
you can because if they're parallel, then you get of course. But no, you can't do that.
Yeah. Well, we don't know that this
Because
side
we
is
don't know
parallel to that
one's parallel to
side.
that side is what I. Yeah.
Yeah. I guess that maybe you can't. I don't know. It'd be worth
I was actually
taking a look at.
That's what I was gonna do, but then I realized it was just.
Yeah. Let's see how the book does. The book give me an answer? Nope. They don't ever give you an answer for proofs.
Well, that's the other do.
Well,
they give you in the back.
not the teacher edition.
They give it to you in the back.
Yeah, the
But
back
16
is-
is
Well, we can look at 17. That's close to it.
Do they always give
17
you?
isn't a proof.
Do they always give you odd proofs or the answers to all the odd proofs? Do they?
Yeah.
always?
They do,
Okay.
yeah.
Let's see. I want to check.
You can look at the end. I mean,
Ooh, corner. Curious.
Page 169.
occasionally, if I can't get the problem, I'll look at the answers and then try to figure out why the answers are that. But I barely ever look in the back of the book.
Yeah, I check my answers.
All right, written exercises 1. Let's see. Did I get 1 right?
I don't know. Let's see.
Nope.
Any questions?
Nope.
I couldn't figure out the value for B on number
9 and 10 were tough.
Yeah.
9 and 10 were tough.
Yeah, B was hard.
All right.
It did, but you have to find out. You have to have X and Y to figure out B.
10. Yeah.
Oh. Well, what the? B was 8, wasn't
This is B.
Yeah.
Is it this piece?
Wait,
It's a
no,
little
no,
piece of
it's
B
not
is
6.
eight.
eight,
It's
B
not
is
eight.
B is
It's
4.
How would it be 4? It's right across from 8.
Jeez.
It'll be by the.
There's no 8 on number
Wait,
10.
not replacing my phone.
There's
Number
no.
9. Oh, wait, we're talking about 10. So,
Yeah.
yeah, I did. I got that.
Yeah, you're right, B will be 8.
Your total's a parallelogram, so this side's B, and this side is 10. So we got A is equal to 10. Easy. If this is 90, then X is.
90.
All right, so that one's easy.
And then
And
B,
so it'd have to be.
So that's got to be
So
45,
it's-
That's
be an
my
isosceles
isosceles
triangle.
triangle, which
Yeah.
means C
which
would
was
be
means
4.
B is 4. So what was the hard part?
Dang it, I got
it
the
was
mixed up.
at, well, it was
It was
probably
just like
knowing that it was
thinking
an
about it.
isosceles
Right.
triangle.
And I will say, I thought that 10 was easier than 9 because I wasn't expecting there to be a isosceles triangle in 9.
Yeah.
But since I did 9, now I'm at, oh, I better look to
Actually,
see if there's an
two
isosceles
isosceles
triangle.
Yeah.
I got Y and X mixed up. I thought Y was 90 and X was. Oopsie.
Okay. Anybody else?
21 and 22.
That one I kind of.
21 was easy.
Yeah, 5X equals 35 and 80 equals something. That one I didn't get.
Although 22.
21 or 22, McKinley?
Oh, 20. Ali asked the question.
But you didn't get it either?
I got,
Get it.
Yeah.
I don't think I
felt
got
really
it.
confident about my answers.
Wait
And then
a
80.
second.
80.
Why do they put, oh, they're just saying that this
That
whole thing is
80.
80 degrees.
Oh, well, then yeah, you could
Then
do 6.
this plus
Then
this
there's also.
is 180, and then we've got 35 over here.
You could do 80 equals
So then
So we
5X
got 80 plus 5x plus 6y plus 5 equals 180.
That's the hard way to do it, though.
Oh, that's
Well, probably.
You would
Let's
just
see.
do 85 equals 6y plus 8.
yeah, I didn't get that one. I got 5X equals 35. I'm confident on that one. But the other one I didn't.
So what he's saying is these two, right?
It's parallel.
Parallel cut by transversal. So we get 35. Is
No, 85.
that 85?
No,
Eight.
it's 35.
It's 35. I was right.
Oh, okay.
35 is equal to 6y plus 5. So therefore y is equal to what? 6? Is that right?
5.
5? 36. 5. Okay.
Haha, that's point.
All right.
Aha.
That's like 3 points for
So
me.
this makes this 30, and then we can solve for x.
So I have 3 points right now.
Oh, you're lucky I gave you that one. All right, that's 21.
A lot of people.
And then
are
22,
getting
you had to do a system of equations.
Thank God we finally got to do that. I'm still waiting for the quadratic must be coming sooner or later.
Yeah, it's going to come when we get areas.
All right, 22 or not 22? Okay.
20.
Yeah, so 22 is, even for an honors class, I wouldn't put it, maybe as a bonus question, but I wouldn't give you a system of
22
equations.
was pretty easy.
Well, if you thought it was easy, then you didn't solve
I
it.
thought 22 to
Oh,
25 was
wait,
easy.
yeah, I get that. I get how that could be. Oopsie.
So this is x minus
I
1.
was very tired.
This is 130. This is 85.
We don't solve this in class.
Did we?
We remember we did the whole 130.
I don't remember this.
We did a 110 kind of thing. We did one that was like similar to this.
All right, well, let's see what we got here. Then x plus y
Equals 85.
equals 85.
And then if that is 130 and that is 130, and then if 130 is supplementary to the other angle, then the other one must be 60. So then it's 60 and 60. And then if 85 plus 60 plus x equals 90,
So this angle right here is
60.
what?
60.
How about 50?
Yeah, it is 50.
50. So this angle right here is 50. So therefore this plus this plus this, 180, right?
Well, you could do it that way.
So x minus y plus x plus y plus 50 equals 180. There might be another way. I like this because look what happens.
2x plus 50 equals
The y's drop out. So you get 2x plus 50 equals 180. Therefore, x is equal to
130.
65? Is that right? 65?
Yeah.
So x equals 65.
Yeah.
And-
then y equals 20.
And we get that from right there. Okay. That's how I would do it.
Man.
You had a different way?
Yeah, I did it.
Because that
and-
really isn't. So
then
when
I
you
did
did a
it-
system of equations, I agree these are two equations, but I didn't really
I
solve it using a
I
system.
used a system of equations.
Okay, what'd you do?
I did 50 plus 85 equals 180.
Where did you get a 50 from?
Because the 50 on the other side first.
Okay, so this one, right? This one or this one?
That one.
First or second?
Second.
Okay, so that's 50. Okay.
50 plus 85 plus x equals 90, and then I figured out the other
But you
angle.
can't say that's x.
Why not?
Because I've
fine.
already used x.
Fine.
Z?
Plus z.
Okay, so you said 135 plus z equals 180.
Yeah.
Okay, then what?
And then I just figured out what, and then I just did subtract the 35, and then I got z equals what, 45?
So I'm still, is that right? 45, so yeah. I'm still waiting for you to use a system of equations.
And then once I see z is alternate interior angles to x minus y.
So it's not a system of equations. 45 is equal to x minus y.
And
Okay.
then I used 85 is equal to x plus y, and then I added those.
That would be a system of equations.
Yeah, that's what I did.
Okay.
Actually, I subtracted them.
So
because I
x
made it
plus
a small
y,
number.
why don't you just add them, is equal
Because
to,
I-
is that 85? Yeah.
I subtracted them because I make it a small number and easier.
Yeah,
to
but you
divide.
got an opposite right here, just add them.
Well, it's just easier for me to divide once I subtract. So and then the 5's canceled out. So I just went 2y equals 40, which seemed easier to me than 2x equals 130.
That is literally the same thing we got.
Yeah.
So it's 2y equals 40 means y is 20.
Y equals 20.
Did we say that before?
Yeah, we did.
Okay, cool. All right, well, there's a different way. That would be using a system of equations right there.
Yeah, that's what I did. I did that for every single problem for 22.
Okay.
24.
All right, have we gone over them all by now? All right. One is CR and CE. 2 is angle REC and WCE. Now remember, you can say them in different order. Oh, there's 3 of them. I'm sorry. REC, WCE, and WEC.
I got a little. Okay.
On 2,
Yeah.
if WR is perpendicular to CE, name all the angles that are congruent to RCE. All right. Number 3, side ER, RC, and CW. And remember, it can be said backwards. Number 4 is angle CRW, CWR, and EWR. All right, 5. A is 8. There's a lot of 8s here for A's. A is 8, B is 10, X is 118, and Y is 62.
I'm gonna get those ones mixed up.
6, A is 8, B is 15, X is 80, and Y is 70.
Oh, come on.
7, A is not 8 this time, it's 5, B is 3, X is 120, and Y is 22. Number 8, A is 9, it's close to 8, B is 11, X is 33, and Y is 27.
I'm gonna get those.
9, we're back to A being 8, and so is B, and X is 56, and Y is 68.
Almost got it this time.
And 10, we already did. A is 10, B is 4, X is 90, and Y is 45. Perimeter for number 11 is 60 units. Number 12, ST is 14, and SP is 13.
Okay.
We'll skip the proofs and go on to 16, which we did.
17.
17, 3, comma 2. 3,
Oh,
comma
yeah,
2. 18 is 5, comma 5.
Oh.
19, X is 3, Y is 5. 20, X is 7, Y is 18. 21, X is 13, Y is 5.
Oh, we got that one.
Wait, on 21?
21, X is 13.
Why would it be
Y is
31?
5.
Wouldn't it be 5x equals 35?
Did we just do this one?
No, we just did 20.
No, we did 21.
Oh, okay.
Yeah, I see what it
Did we
is.
get 13 or no?
Yeah.
Okay.
I got 9.
22, we just did 65 and 20 for X and Y.
Nope.
23, X is 5, Y is 4. And 24, X is 10, and Y is 16. That's it.
I did the math.
Not great.
Ben, are you here? I've been lazy the last couple days.
Then we spent the first 20 minutes of class on this.
Was he here in Latin or no?
No.
All right. All you need is your book of truth today. So I remember getting this class in high school and being like, slightly overwhelmed, like I understood everything, but then all of a sudden the totality of it kind of hit me, and I was like, that's a lot of stuff. So I didn't get a book of truth. We had to have it all memorized, but you guys got a book of truth. So you should not, even though if you feel slightly overwhelmed, it'll be fine because you got a book of truth. And if you keep things nice, neat, and orderly, it'll be okay.
Wait, how can you memorize all this stuff?
Exactly.
I barely ever use my book of truth.
Well,
Like, I barely ever even open it.
I mean, I use very basic stuff.
we're gonna get 5 things today. 5 things. And then tomorrow we're gonna get a bunch more. And it's gonna be a lot of stuff. Therefore, we're gonna take a pause. It says no, I was about to say quadrilateral because I'm thinking of algebra 1.
We didn't have quadrilateral.
Right. We never had that. We had cubics, but not quadrinomials. But we're going to do quadrilaterals. We're going to get a couple more. But primarily it's parallelograms. So it's going to be parallelograms and triangles reviewed on Wednesday. We'll take a quiz. Originally, we're going to have the quiz Tuesday, and I messed that up last year. I shouldn't have given a quiz after this. This is too much stuff. Oh, career day, you explained to you already?
Kind of.
Yeah.
So no academics on this day. You're going to go to every it'll be regular class period, 37 minutes. There's going to be some person, they're going to tell you, they're basically their life story real quick and why they chose this profession and where they went to school and what that process looked like and, what they do on a daily basis. You may be interested in that individual person. You may say, well, there's clearly a job I don't want, but just pay attention to their story. Like, what did they do when they were in high school, getting ready for college? And it'll just give you an idea of what it's going to look like for the next 4 years. And then I think 5th period, we're going to play a volleyball game or something like that. And then 6th and 7th period, they're going to give you a formal, this is what it's going to look like for you, based upon their stories. We're going to tell you this is what you should be doing freshman year, sophomore year, junior year, senior year. Just in general type thing. Like, well, when should I start looking for college? When should I start doing this stuff? For you guys, it's pretty far out. For their sophomores, like next year, they need to be doing it at this time, right now. When you're a junior, in the end of the fall is when you start saying, you know what, let's go take a trip during spring break, during Thanksgiving break, during Christmas break, and let's go visit the campus. Some people like go far away. If you want to go to Hillsdale, then you're going to Michigan to go stand in front of Margaret Thatcher and Ronald Reagan. They have a nice campus. That's done junior year. That's done somewhere between, because I was a teacher and I was aware of all this stuff, I started sophomore year with my kids. I was like, okay, where do you think you want to go? Well, let's go just take a campus tour. They're free. Obviously, the trip isn't free. And then you get a kind of a feel for whether it's a good fit for you or not, at least from the physical nature of it. You can't really tell what the school's like until you actually go there type thing. But you can get a good feel of whether or not, well, this place is a dump. Why do I want to go here? Or holy cow, I saw that classroom and look at all this stuff. That's cool. Anyway. I sure hope this works out because this will work out perfect ending right before a 5-day break. I don't really want this to move over a little bit. Okay, this will make sense when I do it. It won't make sense right now. No.
I've already read this chapter, so I know.
What's the difference between the diagonals of a rhombus and the diagonals of a parallelogram?
Diagonals of a parallelogram.
That was easy. What can you tell me about the medium of a triangle? What's the formula?
The medium of a triangle?
Yeah.
I don't know.
Oh, that was easy.
I was just looking at the theorem.
That is the theorem. I gave both of those. I gave you theorems.
Wait a second. We only have
I just saw the ones that were.
Yes, the 5th one is the definition. Okay, so today is kind of like the reverse of what we did. Yesterday I gave you a quadrilateral. I gave you a parallelogram. You told me something about a parallelogram. Today I'm going to give you a quadrilateral. You're going to prove that it's a parallelogram. It turns out there's 5 ways to do it. It's a lot.
5 ways, but why can't we just have one?
Exactly. All right. So last class I gave you a
Quadrilateral.
that was a
Parallel.
So why is this quadrilateral?
Because it has 4 points.
4 points that are parallel.
What?
It's 4 points that are connected.
Why is this a quadrilateral?
4 vertices.
4 segments joined at their endpoints. Okay, quadrilateral.
So
Okay.
4 vertices still work.
This is a parallelogram because opposite sides. Now, this is the definition. It's already in your book of truth. This is the definition of a parallelogram. If it's a parallelogram, you need to prove that, right? If I give you a quadrilateral and ask you to prove that it's a parallelogram, well, the only way you can do it is from the definition right now. You're going to get 4 other ways. And show me that the opposite sides are parallel. Could you do that? Sure, right? Remember the things we have. The hidden part right here is the fact that 2 parallel lines cut by a transversal, we get to say 3 things. What 3 things? There's actually more, but 3 that I taught you. 2 parallel lines cut by transversal. Hey, that's what's going on right here. 2 parallel lines cut by transversal. What can you tell me?
That the corresponding, there's the
Corresponding angles are congruent.
Same
So
side.
this angle is congruent to that angle.
Same side interior angles are supplementary.
Same side interior angles are supplementary. And the third one,
Interior
alternate
angles.
interior. So
Alternate exterior.
one way of proving it would be that. Show me that alternate interior are congruent, then I can show you that this side is parallel to that side. Show me the same side interior add up to 180, then I can show you that side. This would take a lot of work, right, if we proved it by its definition. So how about we don't? And we look at some other easier ways, and that's what today's class is about. But first technique, right, open up your one to parallelogram. First technique is to show that opposite sides are parallel. That's the definition. So technique number 1 to prove that a quadrilateral is a parallelogram, show me that opposite sides are parallel. And that's the only technique we have so far. You feel he's already reading ahead.
Right?
Okay, now I figure out.
All right. Oh, and by the way, don't forget that's the symbol for parallelogram.
Why do we need a symbol? Why can't we just say it P equals?
That's a lot of letters, isn't it?
I mean, just P.
All right. What were the 4 properties of parallelograms that we've already learned? McKinley give you one of them.
The properties of each other. They're congruent angles.
Which ones?
B and D.
So the,
So segment B and D are.
you just said angles.
Sorry, the angles B and D are.
How do you describe them?
They're lines. They're angles.
Yeah, but how do you describe them?
By some complicated word I can't remember.
How about the word opposite
Yeah.
angles are congruent? Not only B and D, but,
C and A.
okay, is B congruent to A?
Yes.
Look at it.
No, it isn't.
So we're not talking about adjacent angles, right? These two, no, but we are talking about opposite angles. So that's one way, or that's one property. What do you got, another property? Consecutive angles are supplementary. So we can say something about A and B. You add those 2 angles up, you get 180. What else? Diagonals bisect. Now I want you to be careful. Did we say that diagonals are congruent? Jack?
What?
Did we say that diagonals are congruent?
No, they're not.
Right. They could be, but
Yeah.
you're going to find out that, and this is the question I ask you, in a rectangle, right? Turns out they are congruent.
Yeah.
But in a parallelogram, right? Unless that parallelogram is a rectangle, it turns out they're not. Okay? But they do bisect each other. Did we get them all 4 of them? We leave something off? We said that opposite angles. We said that diagonals bisect each other. We said that supplementary or consecutive angles are supplementary, and we left one off. Opposite sides are congruent. So those are the 4 properties that we have. And like I said, I would absolutely make sure they're on your page and you have them starred, highlighted, or something like that. I had to draw a second one because it got too busy there. Wait, where's my 4th one? Oh, I know why. I copied this lesson from the other guys. I didn't want to give them all 4 in the lesson. I thought it was too much to give them in one lesson. So on Friday, they only got these 3. You guys got 4, so ignore this part. This is the new one. This just basically is that explanation of why consecutive angles are supplementary, because it's basically this shape right here, and we know that same side interior angles, these 2, or if you tilt your head to the left, these 2, they have to one. I left one off because there's no space. Okay, so there are the 4 that you guys got on Friday. Okay, all right. So what I said we're doing today is this, right? We're switching around. We're switching around. McKinley didn't look.
Switch.
Oh, you did. Okay. All right. Apparently, wasn't that funny. I'm going to give you a quadrilateral, and you're going to prove that it's a parallelogram, right? So turns out there's 5 ways of doing it, right? Why so many? I love that. All right.
Who is that? Why?
You're a horrible person.
Yeah.
All right. So it turns out we can go by the definition, but if we go by the definition, what do we have to show?
That they're parallel.
That opposite sides are parallel. There's a lot of work there. Okay. So I'm going to give you a quadrilateral. You're going to prove it's a parallelogram. There's 5 ways to do it. The first way is the definition. Got to show it. There's an easier way to do it. One of the easier ways is the next one we're going to prove.
Which is the if opposite sides are parallel, opposite sides are congruent.
If opposite sides are congruent, it's the converse to whatever theorem we had. So we need to show that this is a parallelogram. Oh, by the way, how do you show something's a parallelogram? Since we only have one way of doing it.
Then it's true that they're parallel.
I got to show that opposite sides are parallel.
And we gotta. Oh, brother.
Okay, so how are we going to show that opposite sides are parallel?
We're gonna
Magic.
show.
In general, how do you show? I mean, I already know how this is going to end.
Like alternate interior angles, maybe same side interior angles.
One of those two. So of those 3, which is the easiest one that you like the
same
most?
side interior.
You've got to show they're supplementary. Notice there's no degrees
Alternate
here.
interior is probably easier.
Then all we have to do is simply show that they're right, that they're alternate interior angles. But let's see which one we use. Okay. Oh well, if we want to show that.
I know how to do this.
How?
By SSS for triangles.
Well, there's no triangles there, buddy.
Yeah, you can make
Yeah,
triangles.
construct
Oh.
a line EG.
So what do you want me to make?
Construct EG.
All right. So let's. Does it matter that we make EG? Can we make FH?
Yeah.
Either one's fine. Okay, so let's make that. This is the same thing we did on that previous proof. I left off the extra step that said label, right? You can do that from now on. If you don't want to write a step that says label angles 1, 2, 3, and 4, just go for it and label it, and I'll but just make sure I can read it. Okay, now what?
You do SSS because
No.
of the reflexive property because EG is your TG.
Okay. Then you can say,
SSS.
okay, well, you got to say that the triangles are congruent, right?
Triangle
Yeah,
is
you-
congruent
Now be careful.
to
What do you want to say?
Triangle EFG is your triangle GHE.
All right, you said it correct. Right.
So then,
I chose a different way of saying it, but it's the same thing.
angle FEG is congruent to angle EGH, which means that.
Yeah, that's why I labeled them, buddy.
Okay, fine. Angle 1 is congruent to angle 4, and because angle 1 is congruent to angle 4, then they're parallel because alternate interior.
Yeah, you buy that?
Sure.
Okay. Therefore, what do I write here?
alternate.
Yeah, and you got to be careful because it's technically not that alternate interior angles are congruent. It's the,
If alternate interior angles are congruent.
right,
then
you could say the converse to, I go, no idea what chapter we even learned. Is that chapter 3?
chapter 2, I
The chapter 2? But it's the converse to the alternate interior angle theorem, right? No idea. This is also why, you know, I didn't worry about memorizing the theorems because, okay, I could remember that, but I'm certainly not going to remember numbers. You got it? 4 or 5? Okay. 3, 5. Okay, I thought it was chapter 3. Okay, cool. Oh, what did we just prove?
that if alternate sides of a quadrilateral.
How about opposite?
Opposite sides of a parallelogram are congruent. Quadrilateral are congruent, then it is parallel.
So this is going to be number 2.
Then
all right.
just do this.
So this is theorem 5.4. It's the converse to 5.1, and it says that if you have a quadrilateral where opposite sides are congruent, then it's a parallelogram. That's a little bit easier because of the constructing triangles. That's a little bit easier to do to show that opposite sides are parallel. So this would be number 2, and we'll write down the 5 separately, nice and neat on our parallelogram page once we get all 5 up here. So this is number 2. Of course, they named it Theorem 5.4. They didn't listen to me. This is 5.4.
Yeah,
But I'm saying it's the second technique to show that a quadrilateral is parallelogram. First one is you just got to meet the definition of a parallelogram. The second one is show me that opposite sides are congruent, parallelogram. And by the way, this is the one we just proved. I never changed my homework. If you look at your homework, who's got their book open? I want to say this is question number 11 or number 12. You don't have to do this.
Cool.
McKinley, you got it open?
Oh, yeah.
One of them says prove theorem 5.4. Which one is that?
11.
So we don't need to do 11 because we just did it.
Yay.
All right. Even though I just didn't change my homework. All right. So these next ones are what you're going to prove for homework. Turns out these are pretty easily proven. Okay. So 5.5 says the following. It says that if you have a quadrilateral, look at the board, and opposite sides are both parallel and congruent, then it's a parallelogram. So this one's even easier. I don't need to show 4 things necessarily. I just need to show 2 things about one pair. Although technically that's still showing 4 things. Sometimes it's just easier. And the reason being is because typically,
What is this? Converse to theorem 5?
converse to theorem.
It's not a converse.
Yes, you're right. This is a brand new one, all together.
Why do we even need converses then?
Yeah, we should just go with biconditionals. I agree.
Cool.
All right, so this is technique number 3. Technique number 1, show opposite sides parallel. Technique number 2, show that opposite sides are congruent. Technique number 3, show me that just one pair is both congruent and parallel. Then it's parallelogram. Ben, you here?
Oh no, he's being attacked by cats.
Eating donuts.
The
I
frogs,
vote for donuts, yeah.
What about the frogs? I mean, toads are taking children and replacing them
Well,
with
in
children.
so many children's books, that's the case. Sometimes toads are not evil, though.
Sometimes they're princes. Or is that frog? Stuff.
Frog and Toad.
Frog and toad. You mean that weird
That's the
child's
book
book?
series.
Mhm.
Yeah.
Yeah, but one of them is like lazy and one of them is, I forget which is which.
The frog's
One's always
active.
complaining about the other one. All right, next one, because we didn't have enough of these. All right, so this one, take a look at the picture. If you can show me that opposite angles are congruent, it's a parallelogram. This is the converse to 5.2. This one, if you want to pick this one to prove, I'll be impressed if you guys can prove this, but you got to close your books right now so you don't look at the hints.
I know how I can do that.
You got to close your book.
My book's closed.
Okay.
Fine, I'll close it.
I'm not saying that this is a hard one. It's just that you,
I can do it, yeah.
well, we'll see here in a second.
If we do we get free candy?
No, because we were going to prove one of these in class anyway.
What homework are we getting crossed out? Like,
Well, that's why the homework said cross out the ones we do in class. So you're going to pick one that we're going to prove, and then we're going to cross it out so we don't only have 2 proofs tonight for homework. Then they're both easy, whichever ones are left. Yes?
No.
And it's got to be both. It can't be just one. It's got to be both. So both pairs of opposite angles, if they're congruent, then it's parallelogram.
but what happens if you only have one? Can you move stuff around?
So here's 2 congruent angles, right? I'm not going to move my thing. The issue with this is you certainly can make a rectangle out of this, right? The problem is that if I move this right here, right, these 2 angles between my thumbs and my fingers is constantly changing. So even though you can certainly make a congruent one, but you can also make an incongruent one as well too, even though these 2 angles right here are not changing. So just if you just show that one pair, just shorten this leg right here, right, and connect it, and you make something that isn't. All right. All right, last one. This is number 5. So show me that the diagonals bisect each other and it's a parallelogram. You would think that this is the hardest one to prove. This one is really easy to prove. It's actually, to use it though, requires the most work. I got to show a bunch of stuff there. I got to show that 2 diagonals bisect each other. So to actually use this in practice, boy, this one takes the most work. I can prove it's true pretty quickly, 2 or 3 steps for the proof. But to actually use it, well, I got to show that this piece is the same as this piece, and that piece is the same as that piece. So it can take a while to actually use this one. And this is the converse of 5-3. 5-3 says it's a parallelogram and the diagonals bisect each other. The converse says that if the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. Okay, so here are the 5.
Oh,
I would put this on that page right next to what are the properties of parallelograms. So we get 4 properties of parallelograms, and then you have 5 ways to prove that something's a parallelogram. So this is why I'm saying it's a little overwhelming. That's 9 things, just about a parallelogram.
I'm sure there's more.
Well, about specific parallelograms, so about the rhombus, the rectangle, yeah, there's lots of other things. But this is just in general for any parallelogram. Oh, and by the way, if you need the names next to it, so that is the definition of parallelogram. That's Theorem 5.4, that's 5.5, 5.6, and 5.7. We've already proved 5.4. And I said we would do one more in class, so who wants to pick?
I want to do Theorem
5.5?
5.5. I want to do 5.6 and 5.7 by myself. I've already did.
Yes? I'll just say 5.5 and 5.7 are done pretty closely to each other. 5.6 is the stranger one. So you want to do 5.5? Okay. When you have this all copied down, I'll go back to 5.5 and we'll prove it. About 2 steps. Four is, or 5.6 is also about 2 steps, but it's a little different. Good?
No.
So typically when you're trying to thumb through, your book of truth, it's hard to find these things, but you have them on one page. Oh, it's a parallelogram. What do I need to show? It makes your life a little easier. Okay. 5.5 it is. All right, Anna, you're on. So you're given that this is congruent to this, and AB is parallel to CD. We got to prove it's parallelogram. That what? Well, where are we getting that from? No. Remember, we don't know it's a parallelogram yet. All we know is that AB is congruent to CD and AB is parallel to CD. Boy, I wrote that backwards.
So then angle B is supplementary to angle C.
Whoa, where are you getting that from? You buy that?
Yeah.
Say it a bit better.
Angle B is supplementary to angle C.
So take your head to the left. We know that these two are parallel, therefore.
The bitransversal BC.
Therefore.
The same side two angles are.
That's what I was wanting to say.
Supplementary.
So we know that angle B plus angle C are supplementary. Is that going to get us anywhere? It might. I don't know. But that's true what he said. Okay. Man, I'm all about let's see if we can make triangles, right? Because my real goal here is, right, is to show that, well, I don't know. What are the ways? Well, we got to show that if I can show that this is congruent to this, I'm done, right? Because then I show that opposite sides are congruent, and that's theorem whatever. 5-4, is that right?
Oh, I see it.
Okay, so let's do that.
So then you can say because it's cut by a transversal, then alternate interior angles and reflective.
Okay, so which ones? Oh, let me label. 1, 2, 3, 4. So which ones are?
So one is congruent to 4.
So 1 is congruent to 4.
So 1 is congruent to 4, and then angle A, line AC is congruent to line AC.
So I have
So you have SAS.
SAS, therefore. Well, I don't need to do that.
2 and 3 aren't.
I just call CP, CTC at that point. I'm done.
But you,
I don't think you could say that 2 is congruent to 3
because that would have to be A, B,
until
and C.
you get to the 2 triangles.
Yeah.
Because it's not that these 2 are parallel; it's that these 2. So you certainly, and this is the issue I had in high school too, is of looking at something with a diagonal and figure out which ones were the alternate interior angles. So that's why I literally always say tilt your head so that you don't make that silly mistake. So if you tilt your head, this angle right here, I don't know, because remember this transversal right here or this one of them doesn't exist. So if we say that we're looking at this and that, then that's the alternate interior. Okay. That was easy. So, which ones do you have for homework?
5, 6, and 5, 7.
So 5, 6, and 5, 7, those are your homework ones. I don't know which numbers those are, but
So are we done?
we're going to do a couple quick ones. You may want to look at your book. I don't know if you can see this very well. So you're going to tell me yes or no and why. Yes, it's parallelogram. No, it's parallelogram, and why. All right. First one. Yes or no?
Yes,
Why?
because the opposite sides are congruent.
So that's theorem 5-4. Is that it? Is that right? Opposite sides are congruent?
We do know it's a theorem. That's something.
Theorem 5-4.
Okay, 5-4. There we go. All right. Allie? Ooh.
Theorem 5-5.
Which says?
If one pair of opposite sides of a quadrilateral are parallel.
Okay, that one's easy. Jack? Yay or nay?
Nay.
Why?
Because all you have is one bisector and one side. Nothing about that.
Well, we do have what? Alternate, or we have a vertical, right?
Yeah, but then you get ASS.
And we got an ASS. And that's about all we can say about that one right there. We got an ASS. That's it. Okay, so that one's a no. McKinley, number 4.
Would it be theorem 5, 6?
What's it
Opposite
say?
Sides,
What's 5, 6 say?
both pairs of opposite angles of a quadrilateral are congruent.
Where do you see angles on that one? I'm
Oh,
not-
there is an angle for seg line.
So which one is it?
Theorem 5, 7.
Read it.
If the diagonals of a quadrilateral bisect each other, then the quadrilateral.
That's what it looks like. Okay, back to Ann.
Yes.
Okay, why?
Opposite angles are congruent.
Read what it says for that one.
Both pairs.
Oh.
So no.
Certainly one pair, 70 and 70. Can you convince yourself that these 2 are equal?
Yes.
The issue is this. Imagine this is 70 degrees. Can I not take this right now and tilt it up so that touches like that? This is still going to be 70. This is still going to be 70. But
All you have to do is 70 plus x equals 180, and then 70 plus.
let me try to draw it for you. I'm not going to be able to draw a perfect 70. So we got that 70, and we got this is 70, right? I can still maintain that that's congruent to that, but clearly that's not a
All you
parallelogram.
have to do is construct something, and then there.
I mean, they drew it so it is a parallelogram, by the way. But they're just saying, but that's it. If you don't tell me what these 2 are, no chance. All right, so 5 is no. Who are we on? 6? What?
No.
Why no?
Because there's only one.
How many are named?
Oh, 3, 6.
We could. How many angles are here?
3.
Total angles.
Oh, cool.
And what do we know about the sum of the interior angles of quadrilateral? How many?
34 minus 2.
Which is 2 times 180 is.
3.
So I know that all 4 of them add up as 360. I got 3 of the 4. You use some algebra to figure that out, right? And it's going to be 110, so therefore it's a yes. So be ready for that one. All right, Jack.
Yes,
Why?
because then you can cut a line DB, and then you can say because of alternate interior angles, angle CDB is congruent to angle ABD, so AAS. And then you can prove that those two sides are congruent, so they're parallel and congruent.
I didn't hear a word you said, but maybe it's true. You could also say 2 parallel lines cut by transversal. What do you know about this angle and that angle?
90. Oh, yeah, you're right.
Supplementary, so that's 90, and same thing over here, so opposite angles are congruent. What did you say? Make a triangle?
Yeah, I said cut line DB. I said make line DB.
Let's see if that works.
And then alternate interior angles. So you get that, and then reflexive, so you get AAS. And then you can prove that that congruent is side, the 2 parallel sides are congruent.
I'll buy that.
By
That'll work.
CBCT.
Sure. Sure. Wait a minute. So we would get that that is congruent to that.
And that the parallel sides are.
Oh, gotcha. Yeah, yeah. Okay. Yeah, that'll work. That'll work. That'll work. Okay. Kinley, 8?
Yes,
Why?
because opposite angles, no, not opposite,
That's not opposite angles.
that's not angles, that's
Clearly, this piece of the opposite angles are congruent, but we can't say anything about that, nor can we say anything about that and that, unless we prove the 2 triangles are congruent. Are the 2 triangles congruent?
they're both 90, so you can use the.
How do you know?
Oh, wait, you can't figure that, so no, you can't do.
Right. I think you can get what, an ASS out of that as well?
Yeah, but you can also get that DC is parallel to AB.
Hmm.
And that's the only thing you'd really get from it. And then you would have to prove something at the other side.
If we would somehow show that this was parallel to that, yeah, then we would be there. But I don't see anything else that we can get from that. Well, we could get that this and this are supplementary as well, but that still doesn't get us anywhere. Okay, so this one's a no.
It clearly is one by.
This is a harder one. Nobody in period 2 can get that one.
Oh, I got it.
You got to tell me it's yes or no, though.
It's yes.
You got to tell me why.
Because of alternate interior angles for each side.
Okay, so that would show what?
That
That there's that all of them are parallel.
The definition.
I never saw that. Boy, that's a whole lot easier.
What did you do?
I split it up into 2 triangles. I split the top triangle and the bottom triangle. So I had this, and I had, where's the other one? This, and then I showed that those 2 triangles were congruent. And then, anyway, yeah, I like your way better. Yeah, that was way easier. All right, e-learners that are not here today, that will do it. Send me emails if you have any questions.